catch this number. But anyway, this one shows the same unit as watt per square meter. That is maybe because of these ones are based on area, right? Okay. So tidal also, I'm trying to show this time current, but anyway, those figures are similar. Only one, twice, or so, triple comparing to the other gas and coal. So that is the baseline of renewable energy, the weak point. So that is the economy, and size also should be bigger for comparing to the traditional technology. Right. So current energy is coming also coming from wind and also density differences. So ocean current, there are two kinds. Surface current is up to 100 meters depths of water, and this shows probably the surface current map, because it's not easy to measure the deep ocean currents. It can be measured, but it is not easy to make a map like this one. And surface current is driven by wind, and so there are coastal currents. So near the Korean peninsula and Japan, the Kuroshio current is very famous, and they are saying this is strong. So and also you see this, the red color means warm, the high temperature. Then this is cold. It is natural that from the equator line, it is warm water is coming down or up, and then from the South Pole and North Pole is coming down or coming up, or cold current. So you can see that Kuroshio current is very warm from the equator line and very strong. And deep ocean current, we saw this one when we learn about acoustics, right? Ocean water acoustics. Same as there is layers of different temperature and density, so that between them there is a gradient line. You remember this for the acoustics? There is a global conveyor belt, means that there is a underwater, deep water stream. So they move like a surface current, same as this one, or under the surface. And energy potential, speed is very slower than wind, but water is 800 times more density than air, so that we are comparing the energy density or power density. The 12 miles per hour ocean current means same as in terms of energy density or power density. It is 100 miles per hour. This is very strong wind, right? Strong wind. And this is looks like slow ship, very slow ship, and that is comparable. So Gulf Stream, in Gulf Stream of the United States, 1,000th of the energy. If we take gathering, collecting energy coming from Gulf Stream, may be a big amount. All right. And sorry for Korean language. There's currents around Korean peninsula. This Korean peninsula, and then you see that there's a strong stream in east side near Japan. In here, there is not so big current. So I said this is a Kuroshio current coming from Taiwan and Philippines, and then the strong currents going around Japan. Okay? So this may be the biggest one, mainstream. But still there is some stream toward between Japan and Korea, and also a small bit down here. And Kuroshio current again. Okay, you see that there is a Korean peninsula and Japan is here. So Kuroshio current is this portion of it. So side of the clockwise North Pacific Ocean, and also this one once again. So this is the mainstream. The one is mainstream. So there are researchers in Philippines, Thailand, and also Taiwan and Japan. They want to use this strong current to convert it into electricity. All right. Once again, this is you can see that Kuroshio current running on Pacific. We saw this video before. Right? Okay. Remember this. And this is where is it? North America. Right. So Florida and Gulf Stream. Yeah. Right. We move on to South America. You see that there is also strong motion there. And South Pole and Africa, South Africa. And we move on to India, Middle East and India. This is Ceylon and India. Right? And then Indonesia and Australia maybe. Yeah, this is Australia. And Philippines. Right? And then Kuroshio current coming. Taiwan and Japan. Korea has very small portion there. So current-wise also Korea is not so strong. Right. Okay. And then the device to collect energy coming from current, ocean current, is very similar to the wind power generation. Right? Very similar. So there is an idea when we research on wind power system, especially for floating type wind power system, we can combine the current power generation system together. Right? So floating type can be balanced by weight and size, so that above water there is a wind power system running, and underwater system there is a current generation. So similar system can be used. And submerged water turbine, you should know that system should be fastened to the floor because it can be moved because of the current. Right? Horizontal and vertical is. All right, and also there is an idea something like a parachute type. And they are fastened into the bed by using a cable, and it looks like a kite, in the air. So the system is very similar to the wind system, And there is also farming, wind farm or current farm or parachute farm, you can say. And then energy, where energy is currently located in there is three major current in the United States. One is Gulf Stream. This is Gulf Stream, Gulf of Mexico, and Florida Strait. There's a current also, and so there are Florida Strait or Gulf Stream. They are saying loop current. We already see this one, loop current. Rotating loop current. I don't know whether I show you a video the other time. And California, the west side of the United States, there is a California current. Okay, that may be coming from north side to down. And the other one is thermal energy. This different topic. And there is two types of thermal energy. One is a geothermal energy that is coming from the land. Soil, there is a melting pot in kilometer 4 and 5 or 5 kilometer. There is a hot region of Earth, so that you can use some pumping down the cold water, then you can get a hot water or steam. So you can use this one as a generation. But we are working on ocean thermal energy. That is similar to this one. We call this is OTEC, Ocean Technology Thermal Energy Conversion. Alright, so I have one more video. Last night I include this one. So you may not have this one. This is just graphics. You see that there is a 25 or 4, so about only 20 centigrade differences of temperature. We use very small differences of temperature differences. Probably 1 kilometer down of depth. And also they use ammonia for easier evaporation in low temperature. And the other things are very similar. So they use cold water from the deep ocean and warm water in surface. So there are about 20 degree differences only. Okay. Let's stop this one. So there are other videos you can find. Okay. Right. So that ocean thermal energy conversion. There is a top layers of ocean have solar heating, so that sun gives you warm water, especially near equator line. The water is around 25 centigrade. And cold water is coming from deep ocean around 5 degree. So that temperature difference is around 20. Okay, and then it is coming from natural temperature gradient or differences. And then only this small difference, but you can also generate electricity. Still, there is a problem of power density problem there. Well, anyway, there is ideas. Right? Okay, return back to geothermal. Because geothermal is very, you can find the big temperature differences. Very hot water can be collected, so that there is more potential there. Right? Because this temperature is very high or more, but you can use enough because you need to have a steam coming from the water. So 150 is enough. And then you can use for space heating, conditioning, or drying, greenhouse, aquaculture, hot water usages. But also, you can have more than 150 degree, more hot water or solution, then you can use for electricity generation. So, same idea as injecting the cold water into the cold water into the well, hot well. Then you can get hot water. Usually have two lines, production wells. So hot rocks inside the globe or land hitting the water up, and then the pressurized water because steam is coming, and then the steam turns the turbine so that you can use electricity generated. And then cooled water is collected and also circulating down. So that is same as the other steam turbine generation. Same as nuclear power, coal power, and others. Right, so this may be the last slide coming from myself. So how can we use, once again, there is a sometimes they use organic fluid that has a lower boiling point when the temperature difference is not big enough, or maybe less than 150 degree. Right? Then same as ammonia we use for ocean technology, summer technology, and then steam generate electricity through the turbine. Right? So this one figure gives you the same idea as heated one, and cooling down, and turbine rotation, and generator gives you electricity, and heat comes from the summer. Right? Then, okay, that's it. What is the picture is there is one site in Diablo maybe in the United States. Okay. Question? Then we move on to next.
As you guys know, the solar energy has a really big energy potential than any other renewable or non-renewable resource. Only use up with the 0.02% of solar energy, you can replace all the other energy. And you can see the size of the solar energy box, and the smallest box is the size of global consumption. So you can know how big the solar energy it is. And the remaining two sentences talking about how big it is, solar energy. Energy radiated on the Earth in 1 hour is greater than all the energy the world uses in a year. And energy radiated on the Earth in 1 year is more than twice what could ever be obtained from our non-renewable source. And since ancient times, the technology has been developed to take energy from the sun. There is a better technology to get a solar energy, passive, active solar energy heating, and concentrating solar thermal and photovoltaics. And I will cover each techniques in each slide. The first thing is passive solar energy. There's no additional material to get a solar energy. But the most key design point is locate the house, the place where the exists lots of sun, and also the placement of window also important to heat up the household. And next thing is the active solar heating. There is some components to get solar energy from the sun. The key material is a collector. There is two types of collector. The first thing is a flat plate collector. This shape looks like this flat plate, and inside of the plate there is some tubes can go through the working fluid. Then the working fluid will absorb the sun energy, and with the exchange of the working fluid and the household water, then we can boil or some heating up the household water. And the next is a evacuate tube collector. It looks like a tube shape. Inside of the tube there is a heat piper made with copper, and this heat piper can absorb some sun energy. Then also, as I said, same mechanism with this one, and we can boil or heat up the household water. This can be a supplement video. Okay, the sun will heat up the solar panel. Then inside of the tube, the working fluid will be heat up, and the exchange of the between working fluid and household water, and we can boil the household water. And the working fluid and the household water will not mix or will not indirectly. That is an indirect system. That's all. The next thing is portable text. It is mostly most useful of the renewable energy technologies, and you can easily see the portable text in the small calculators or your wristwatches. And the mechanism is you can generate electricity from the sunlight using some silicon or some PN type of the semiconductor. The last one is concentrating solar power. It looks like this picture, and with a curved mirror, and you can make the same focal point, and you can heat up the same focal point, and using with the boiled working fluid, and working fluid can rotate a steam turbine, and the turbine will generate electricity. This is a simple schematic of the concentrating solar energy. A little bit different before I said, but this is lots of solar panel with having a same focal point on the storage tank. Then the storage tank will be heat up, and with the exchange of the working fluid energy, then working fluid can exchange the other working fluid. Then this with the principle of the Rankine cycle, and you can generate electricity from the solar energy. And the next topic is the aquatic biomass. You can reduce the area because it does not need a agricultural land in the land side, and also natural or artificial wastes or some salty or contaminated or fresh water can be considered for the exploitation of resource recovery. And usually the fishers are interesting candidate because we can treat the water and grow some aquatic biomass. This is just a simple comparison with the various biofuel. The microalgae has the great oil yield possibility, but the cropping area in United States has the lowest value. And this is the picture of the algae farm. Maybe you guys already seen of this green algae. It is located some in natural lake or some artificial lake. And algae is a simple through the simple photosynthetic organism that could be happen biofuel. And this is how to gather aquatic biomass. Usually the aquatic biomass is made up of some marine plants or microalgae and seaweeds. This kind of aquatic biomass can be used for even in food or biofuel or chemicals. And this picture is how to gather aquatic biomass from the ocean. And yeah, this is all done. Thank you.
So first, what do you think of implementing algae farms in the sea? Do you think we should develop them or not? For example, I brought a study about like a case in Mediterranean Sea. There was a leak of an algae, and it totally invaded the coast, and like the environmental from the coast was totally destroyed by this algae. So I want to hear if you have any like ideas about or any like advice about developing the algae farms, and in this case, if yes, like what kind of problem should we emphasize on? Like, for example, containers, or should we put it on the land like this on this picture? I don't know. Do you guys think that algae are sufficient like energy input so that we risk to harm the eco like the environment?
What is taxifolia?
Taxifolia is like a species of algae, which is a kind of algae which has leaked in the Mediterranean Sea, and it's spread out so fast that you cannot contain it. It's usually found in Australia, I guess, or South America, but it was introduced by mistake in Mediterranean Sea, and now it's colonizing all the reef. Yeah, Bart?
The example on land, not in the sea, right?
Yeah.
Just on land.
I know, but there's also algae farms in the sea. So I wonder, should we stick to because those are obviously obviously drawbacks, like land use, basically. This is like we use land to produce algae, which is supposed to be in the water. So it's like one drawbacks from another. This is more safe for like environment, obviously, but for land use, it's not even like good for the yield, or I don't know. It's like, I mean, it's my personal point of view, but obviously, if you think that we should use the land to farm algae, which is not natural, yeah.
Well, what do you do with the algae? Do you produce energy? Can you eat them?
Yeah, like he presented before, you can produce energy from algae, like biofuel. Sorry.
Well, then it's good, right?
Okay. I guess it's you can put it as the same side as corn, even if I think it's not like as land efficient as corn. But anyway, yeah. Ivan.
Do you burn the algae after it's grown?
I guess it's not burning, but you just like press it to make a fuel. Like this kind of tubes are basically fuel.
I don't know if my knowledge is right, but you can use algae also for cosmetics, for medicine, for pharmacy. So
Yep.
there are a lot of fields that you can exploit algae. So
Yeah.
it is a good idea to.
Yeah, but I mean, like, if you use it as fuel, you cannot use it as a cosmetic.
No,
I mean, like the
there's no
research,
field-
the
there's
research.
No field to use it, so
On land or on water? That's okay. On land. So you all partisan of like producing algae, which is naturally underwater on the land.
The advantage is that you can do a carbon dioxide capture. That's why it is really interesting technology.
Yeah. Okay. Okay. I didn't expect that all the people would like to produce algae, which is supposed to be underwater on the land.
But they're in the water on the land, so I don't see.
Yeah. But
I mean, the algae don't care. I think they don't even know where they are.
I guess the investment costs in general, the maintenance is much higher when you do this on land. So
It's can be way more efficient on land. You have everything in control. They look
yeah, but
on land.
like
It's way more control.
you control, but when you just have a huge amount of algae, it's just a natural environment. You don't have to do anything. It's just grows there. You just have to.
Then you have to pick them up, and you have to.
Yeah.
I think there's way cheaper than in the sea.
you think? I'm not really sure. Like to oxygenate all this water, you need to make a flow, right? And producing artificially a flow, it's like you need to input energy to oxygenate the water, right? Or in the sea, it's natural, like natural process. So in any case, by doing something artificially, you need to input energy in it. So yeah, maybe like the costs are like if you have to produce like you said like to crop like recop the crop, maybe it has a cost on the water like in the sea, and it's less here. But I guess you have nothing for nothing, so it's basically an optimization, and it's a discussion basically. So yeah, if you think that this is more efficient, maybe. But Tobias, I think Tobias has an argument too.
We don't have the numbers from
Okay, so I'm gonna this was a brief introduction to my next topic. Okay, so this one is more about ethics, and it's like an endless debate nowadays. So if you consider that more than 10% of the world population is under malnutrition, what do you think of using eatable food like corn or soybean or coconut as fuel? Like basically these people die of not eating corn, and you take this corn to produce fuel. And so I want to hear your point of view about it, and then shift to like a bigger topic, which is, should we consider science breakthrough independently of any ethics? Like, should we prefer to improve the science and discover new things or new innovation, and independently of ethics, or should we care about it? I guess there could be pros and cons from each side. So I really want to hear your advice on it. Yeah.
I think we should not use eatable shit for fuel. Just not. I think science breakthroughs are dependent of ethics, because ethics is really important in science.
Okay. Is there any cons? I mean, yeah, obviously the point from the food is really like good, but according to the ethics, do you think we should always stick to the ethics? To
I guess what is the alternative when you don't go for like corn or algae? You have to use other sources. Then you say, okay, it would burn more coal or more oil. It's bad for the environment. It's also like influence the life of tourists, because when we have climate change and other things, then there's this argument like in the longer term, it's also maybe worse than using corn. And also the point like when we produce corn, say back in Germany, and or other food, is it possible to transport all of it to another part of the world? So I guess it's not a bad idea to use food for fuel.
Well, you say that if you don't use food to produce energy, the only way is gas or coal, but that's of course not true. You have a shitload of other ways to produce energy.
Yeah.
And I think the transportation, you can transport everything everywhere over the world, so that's not an issue. So I think it's really arrogant of the Western world to just burn food while the whole of Africa is starving. So I think you cannot explain that you burn food. Just not possible, in my opinion.
Yeah.
To me about the ethics, what I think is likewise science develop or science changes, ethics is also changing. So,
That's a good point.
we must not prohibit the research. We should not prohibit the research itself. But if there's a time to make it into a mass production or something, then ethics can.
Okay.
Then in that state, ethics should do something.
So you think that, like, for the initial prototypes and like if you have to discover, then it's the ethics come after, like when it's make wide public, kind of.
Yeah.
Okay, that's an argument. It's different of scales. So the science in itself shouldn't be like stopped by ethics at first level, but if you discover that this technology can harm the bigger number, maybe.
Of course, a scientist himself should have his ethics. I mean,
Yeah.
I want to make a difference between the ethics of individuals and the ethics of the public.
Okay.
I think you can
Answer.
look at it a bit broader. It's not only about the mass use of sciences, it's only about the initial idea. If you discover something that can destroy humanity and you say, this is bad, I discovered it and I sort of knew that it may destroy humanity, but now I stop, and some terrorist steals your idea and destroys humanity, then it's also a bit your responsibility because you discovered it and maybe you knew that you would have the potential to do it. So it's also when you do small amounts of science that you have an ethical responsibility of the possibilities of your discovery, I think. It's more than what it's going to be used for, or what you use it for. It's what it can be used for.
So you obviously speak about a weapon, for example, but if we speak about like some less scale, I would say, for example, clones, like gene modification. The research is currently like struggling against like really strong ethic groups. We don't think that we should like touch in any mean at the genes because it's natural. It's like Mother Nature doing its stuff, and so the research is actually really struggling about it. But we could have some disease medicine, for example, from genes, or so for example, this is like not a weapon, but some other field that can be discussed in this discussion.
And the question, is it not a weapon? Do you think that we can see all the consequences of gene modification?
Never.
Exactly, but how can you say that it's not a weapon then? Maybe the terrorist makes some kind of killer disease out of it.
So you stop making discoveries because you think that everyone can use anything in terms of a weapon. Do you really think that Volta?
I don't say you stop. I say you should know what consequences it can have.
Yeah, but for example, Volta, when he developed the battery, he didn't think that one day this battery can be implemented in some missile or I don't know. It's like, it's a small part. But
Everything can be used for bad. It's
yeah.
just that you should consider it and think, all right, this is the risk, and should I continue with it?
So it's always a matter of like introspection, like facing the consequences to your own ethics. Okay. Any other like ideas about any of the topics we discussed? That can be food, biofuels, clones, ethics, like the difference between ethics, like because ethics is quite subjective, and objective science is kind of willing to be objective, but the scientist is like the person which integrate this paradox. You're gonna make some breakthroughs soon enough, I guess. So this is a topic you should think about, especially if you work in a lab. Okay. Anyway, thank you for your participation. And, this is the last discussion, so I hope you'll enjoy it. Thank you.